Great Gothic churches were built throughout medieval Europe, including this 14th century cathedral in the tiny city of Frombork, or Frauenburg as it was then called, on the northern coast of Poland. People have always tried to make sense of their lives and of the world they inhabit. In the Europe of the Middle Ages, it was to the Catholic Church that ordinary people turned for most of the answers. For all over medieval Europe, the Church, with all the trappings of political power, was the dominant cultural force. Its teachings affected every part of human life. Remote, often looming mysteriously through the Baltic mists and isolated on its low hill, this cathedral at Frombork was the religious center of the small independent state of Warmia. For all the members of that church, from the bishop down, this was truly the center of their world. And in much the same way, they all believed that their world lay at the very center of God's whole universe. The church, along with almost everyone else, took the common sense view that the earth did not move. It was solid and stable. And it was down here. And heaven was up there, beyond the stars. They knew that every night stars appeared in the sky and gradually moved around the earth. In the same way, the sun moved around the earth once a day. Everyone could see that it rose every morning in the east and set every evening in the west. This was the classical earth-centered view to which Aristotle had given his authority as early as the 3rd century BC. It was not until the 16th century that this belief was seriously challenged. And that challenge was located here at Frombork and at its cathedral. Surprising though it may seem, the man who claimed that it was the sun and not the earth that was at the center of the universe was a member of this cathedral, a canon called Nicholas Copernicus.
His mentality doesn't fit to the picture of a great revolutionary. And I think this is the very peculiar feature of history, that a very quiet man moves the earth. It's not somebody who makes lots of noise around him, it's somebody very quiet, very concentrated.
It is also surprising that Copernicus developed his revolutionary theory not in a great university city or cultural center, but in what he himself called this remote corner of the earth. How did this immense revolution in human thought arise from such unpromising beginnings? We have to go back to the early years of Copernicus, long before he came to Frombork. In 1491, when he was 19, he was sent away to study at the University of Krakow, the second oldest university in Central Europe.
He came here because he was sent by his uncle, who was Bishop of Warmia. So this is, let's say, the very simple reason. But second, it was one of the very important stages of education of, well, lots of people, not only from Poland, but from all the neighboring countries. Anyhow, for those times, it was a very important center, with lots of students coming from all over the world, especially to study astronomy. And at that time, it was flourishing.
And Krakow itself was flourishing, the capital of a large commonwealth of Poland and Lithuania, and home to the King of Poland. Krakow itself was at the crossroads of Europe, situated where two major trade routes met. One running south-north, and the other, even more important one, bringing exotic goods from the east into Europe. Krakow became a thriving trading town on the river Vistula, with many traders flocking here from the neighboring German states and from Italy and Armenia. Krakow's huge market square, the largest medieval market square in Europe, is evidence of its importance as a trading center. The town had a cosmopolitan air. As well as a center for trade, it was a center for new ideas from the east and from the west. It was a proud city. But these were turbulent times, and the cathedral was surrounded by defensive walls. Then, as now, the city was an important religious center. The streets were thronged with young men nearly ready to enter the ministry of the church. The church was Copernicus's intended profession. But first, like everyone else, he went to the university where he studied the foundation courses in the Faculty of Arts, including music, mathematics, law, and theology. Krakow University also placed great emphasis on the ideas of Aristotle in both philosophy and physics. In many ways, the university was virtually a sub-department of the church. For example, on admission, Copernicus had to swear in Latin an oath of loyalty to the university and a promise to obey church law.
Ego Nicolaus Copernicus, Juro vobis domino rectori et vestris
I, Nicholas Copernicus, do swear to you, Lord Rector, and to your successors appointed according to church law, obedience in all things lawful and honest, and will promote to the best of my ability the good of the University School of Krakow. So help me God and this holy gospel of God. The university had 3 or 4 colleges in the city. The Collegium Maius, the large college, still stands inside the city walls, close to the marketplace. Here there were lecture halls and also rooms where students and lecturers lived. Inside, the college motto is inscribed on the wall. Plus ratio quam vis. Reason is worth more than power. It was during his 4 years of study at Krakow University that Copernicus had his first major encounter with astronomical theory.
He studied only the trivium and the quadrivium, did his elementary education here, and he never graduated, to be frank, to be quite honest. Now, the hypothesis is that his main interest was astronomy. And this was because Krakow had, since the beginning, the first years of the 15th century, a chair which was specially endowed for an astronomy professor. And then in the middle of the 15th century, the second chair was created by a professor who was a famous astrologer, and again, in his will, he founded the chair of astrology. So practically, contrary to all other European universities, there were 2 chairs where the professor was specially paid for specializing in astronomy.
Today, it seems surprising to study astrology at university, but in the 15th century, the dividing line between astronomy and astrology was a narrow one. Astronomers observed the movements of the stars, the sun, the moon, and the planets. They observed and measured their positions in the sky, and then determined where they would be on a certain date. This information was used by the church to calculate the dates of the church calendar, particularly Easter. It was also used in astrology to draw up horoscopes, considered important for any new undertaking and bringing in handsome payments from rich patrons. Astronomers had long known about the 2 movements of the sun, the daily movement around the Earth, as well as an annual movement in which the sun is higher in the sky in summer and lower in the winter. They all accepted that the stars, the sun, the moon, and the planets moved smoothly around the Earth in circles. Their observations fitted this model in the case of the stars and the sun. But when it came to the planets, there was a problem. they did not make neat circular movements around the Earth. Some of the planets, for example Mars, went forwards and then backwards, forming what the astronomers called a loop of retrogression. And sometimes a planet seemed to move quickly, and at other times it moved slowly. Sometimes it seemed nearer the Earth, and sometimes further away. But according to the generally accepted theory of uniform circular movement around the Earth, the planet should always be the same distance from the Earth and travel at the same rate. The 2nd century astronomer Ptolemy had tried to accommodate all these problems in various mathematical ways. With the first of these, the eccentric, the planet still revolves in a circle, but the Earth is no longer at the center of this circle. It's been moved to one side of the center. As the planet revolves, sometimes it's further away from the Earth, sometimes it's nearer. Ptolemy's second device put the Earth back at the center of a circle. Revolving in that circle was not the planet itself, but a point which was the center of the planet's own orbit, another circle we call the epicycle. Thus, for an observer on Earth, the planet sometimes appeared to move backwards and sometimes forwards. But even this didn't explain everything, and Ptolemy devised a third mathematical strategy to account for the way a planet sometimes appeared to move more quickly and sometimes more slowly. He moved the Earth away from the center of the circle, and he defined another point, the equant point. This was the same distance from the center as the Earth, but on the opposite side. Ptolemy now supposed that the planet's motion would be uniform only if viewed from this equant point. An imaginary viewer here would see the planet always take the same time to go through a given angle. But viewed from the Earth, the planet's motion was not uniform. For a viewer here, the planet sometimes appeared to move more quickly and sometimes more slowly as it went through a given angle. These Ptolemaic ideas were still in common circulation when Copernicus was a student, although some professors at Krakow University were beginning to question these complicated mathematical devices. But mathematics remained the major part of astronomy teaching. It was unusual for an institution to own astronomical instruments. They were extremely expensive and only made to order. During Copernicus's last year at Krakow, the university received a spectacular gift of a set of 3 astronomical instruments, bequeathed to them by a former student who had become a professor of astronomy at Buda: a celestial globe, a torquatum, and an astrolabe. All university lectures were cancelled for the day so that students could inspect them. Copernicus almost certainly had the opportunity to use them and so gain practical experience in observing and measuring the positions of the sun and stars in the sky. The following year, he went to Italy to study law and medicine without having finished his course at Krakow. He was sent there by his uncle, Lucas Wachenrode, a powerful political leader in Warmia and the northern provinces. Copernicus completed his studies in medicine and gained his doctorate in law. But what really interested him there was astronomy. In Italy, there was a new emphasis on the ideas that had traditionally been associated with Plato, Neoplatonism. In the 15th century, these ideas had become freshly available in more reliable translations and were taken up by Italian scholars and astronomers. Many historians claim that Copernicus shared this enthusiasm for Neoplatonic philosophy with its great admiration of the sun and its emphasis on circular motion. And they believed that this was a key influence on his later works. Professor Czartoryski holds a different view.
I would say that he certainly encountered Neoplatonism, and Neoplatonism was also one of the philosophical elements in the Greco Renaissance, in the humanistic movement. But on the other hand, my conviction is that Copernicus' achievement was due to mathematics and not to philosophy. Namely, that what he really learned in Italy was astronomical observation and mathematical calculation.
Circles, spheres, geometrical calculations, and mathematics in general exerted a fascination for Copernicus to the end of his days. This remained true even when he got his first real job as a servant of the church. His uncle, now the Bishop of Varmia, was clearly a powerful man, and wealthy enough to fund this elaborate altar in the cathedral, complete with macabre representations of the Passion of Christ. In 1501, his uncle used his influence to get Copernicus appointed as a canon in Frombork Cathedral. Copernicus did not actually work here for some years. Initially, he had a roving commission as administrator for the diocese, where his training in church law was put to good use. But eventually, in about 1510, he did settle in Frombork and spent his last 30 years working in the service of the cathedral. Strictly ecclesiastical duties didn't weigh too heavily upon him. He never became a priest. But like the other 15 canons in the cathedral, he was expected to celebrate Mass at his own altar. The medical skills he had learned in Italy were called upon, to treat the cathedral's congregation and also to treat patients at this leper hospital of St. Anne's, just a stone's throw from the cathedral. Whatever the extent of his actual duties, he now had both the time and the facilities to devote himself to what had always been his major preoccupation, astronomy. And he continued his lifelong habit, developed in Krakow and in Italy, of observing the heavenly bodies, possibly from this tower, the Copernicus Tower, set within the walls surrounding the cathedral precinct. Nicholas Copernicus had 3 wooden instruments which were described in the work of Ptolemy. Copernicus did not introduce any alterations to these instruments. He used them in Frombork for his observations. They were so big that they required an appropriate place, especially prepared. The simplest instrument is the quadrant, which was used to measure the height of the sun above the horizon. The second, the triquetum, was used for observing the moon and the stars. And finally, the astrolabe, the most difficult and the most complicated instrument, which was used for observing the moon and the stars. In fact, Copernicus made relatively few observations at Frombork. We know of only 42. Often the weather was against him with fog and mist from the Baltic, and often he could not see the sun. But visible or not, the sun began to dominate his thoughts, and secretly at first, he put together a new scheme for the universe with the sun, not the earth, at its center. Perhaps Neoplatonism had convinced him that Ptolemy's solutions failed to achieve completely uniform circular motion and so had to be discarded. More probably, some of his own observations led him to demand a simpler explanation than Ptolemy offered. And almost certainly, he longed for a unified system for the whole solar system, not a separate one for each planet. In this heliocentric system, the Earth was relegated to being just one planet among the many planets that circle the Sun. He showed that the Earth had two movements, a daily rotation as it spun on its own axis and an annual revolution around the Sun. Each planet revolved around the Sun at a different speed. Mercury took 90 days, Venus 9 months, Mars 2 years, Jupiter 12 years, and Saturn 30. Copernicus claimed that this fully accounted for the way the planets seemed to move in strange ways in the sky. Their different rates of motion meant that their positions relative to each other were constantly changing. They were moving uniformly and smoothly in a circle, but around the Sun and not around the Earth. Copernicus wrote, "So, as if seated upon a royal throne, the Sun rules the family of planets as they circle around him." By transposing the Sun and the Earth, Copernicus had completely destroyed the foundations of traditional thought about the universe. This work of Nicholas Copernicus, De Revolutionibus Orbium Coelestium, on the revolutions of the heavenly bodies, was at first only circulated in small fragments among his friends. For many years, several of them encouraged him to publish, including his research assistant Rheticus, the Bishop Gieser, and the clergyman Osiander. His reluctance to go public is understandable. The Church still viewed the universe and the Bible through Aristotelian eyes, and took the common-sense Aristotelian view that the Earth did not move. For a loyal member of that Church openly to challenge this received wisdom might at best have been folly, at worst treachery, especially at a time when the Catholic Church had problems enough with the challenge of the Reformation, then gathering pace in Germany and the West. But eventually he did publish. And in a curious way, his decision may actually have been helped by the approaching Reformation, with its openness to new ideas and its rejection of traditional authority. His great friend and supporter, Bishop Gieser, was a member of the Catholic Church, but he was sympathetic to the Reformation. While both Rheticus and Osiander were already part of the Reformation, they were Protestant, members of the Lutheran Church. Together with Copernicus, they were convinced that his scheme did not challenge the authority of the Bible, for the Bible was concerned with God and the nature and destiny of the human race, rather than the structure of the solar system. Both Rheticus and Osiander saw the work through the printing stage, and the final pages of De Revolutionibus arrived in 1543 as Copernicus lay dying. Shortly after his death, the Reformation was vigorously suppressed in Poland by the powerful Catholic Church, though elsewhere in Europe it flourished. As for Copernicus, his scheme lay dormant for a while, but in due course ushered in a new age of science that, together with the Reformation, was to transform the face of modern Europe.